we'll do the T and then probably one more, and then I want to go on to question 2 because I want to make sure we get some more stuff done. So the first thing that I want to do when I'm trying to get the characteristic equation is to write the characteristic table. So these you need to just know. So we did it on the first page, but you need to know them. I say that and then I wrote the wrong thing. Okay, so that is our characteristic table, and if you recall what the T flip-flop does is when T is 0, there's no change, and when T is 1, it toggles. Alright, so now to write our characteristic equation, we are going to do a Carnot map. So our Carnot map here is going to be pretty simple because I just have 2 variables. So my only 2 variables are T and Q. So when T is 0 and Q is 0, my output is 0. When T is 0 and Q is 1, my output is 1. When T is 0 and Q is 1, my output is 1. And when they're both 1, my output is 0. So there's nothing fancy I can do here for this Carnot map other than to just circle that one and circle that one. And this gets me that Q star equals, so this first circle, that's in the column where T equals 1 and where Q equals 0. So T Q bar. Plus, my second circle, that's where T is 0, so T bar, and where Q is 1. And well, we'll just leave it like that for now. Okay. All right. So that is your characteristic equation. So if you are told to write a characteristic equation, that's how you do it. So let's do SR now. Okay, so we are supposed to assume that the SR equals 1, 1 input is not possible. Our circuit is designed in such a way that that's not possible. That means that our output for those are don't cares. We don't care because doesn't bother us. It's not ever going to come up. So those are don't cares. And if you recall, when S and R were both 0, that meant no change. When R is 1 and S is 0, that was a reset, so this is a 0. When S is 1 and R is 0, that was a set, so this is 1. So we'll do a Carnot map. Zero, 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 1, 1, 1, 1, 0, and 0 and 1. And let's see, I have don't cares in 1, 1, 0 and 1, 1, 1, so that's right here and right here. And I have zeros in 0, 0, 0, 0, 1, 0, and 1, 0, 0. That's not right. because it's not 1, 0, 0. It is 1, 1, 0. That's a don't care. It is 0, 1, 1. Yeah, that's right. Hold on. 0, 1. Right there. Yes. Okay. And then 0, 0, 1. The rest of these should be 1s. 0, 0, 1 is 1. 1, 0, 0 is 1, and 1, 0, 1 is 1. Okay, so see, do y'all remember your Carnot maps? What's going to be the best way to cover this? What do we try to do with the Carnot map? So we want to make as big a circle as we can and as few of them as we can. So grab as many of them as we can at once. Now, what do we do with don't cares? You use them if they help you, and you ignore them if they don't. So in this particular instance, it helps me to say that these D's are 1s, because then I get a bigger circle. If it didn't help me, I wouldn't use them. And then I still have to get this 1, and what's the best circle to get with that one? Yeah, wraps around. Okay, so with this circle of 4 here, my expression is going to include what all these squares have in common. So when I look up at my top numbers, I see that on my columns, S is 1 in both of these columns. So it has S is equal to 1. But R can be anything, so that's not going to be part of it. And Q can be anything, so that's not going to be part of it. So this circle is just represented by S. Now, with this circle right here, what these have in common is both of these squares have Q equals to 1 and R equals to 0. So this would be QR bar. So my characteristic equation is Q star equals S plus the prime is another way of saying not. I think Dr. Trahan uses the bar mostly, but Dr. Veda uses the prime, so you can just get used to that as well. Okay, so that's the characteristic equation. That's how you do that. Now, the next thing that you the next problem that we have here has to do with doing a state diagram. So a state diagram shows you the different states that are possible. Now you'll be working with things called finite state machines, and finite state machines have different states. The simplest different types of states you can have are on and off. But you'll have machines that have states with A, B, C, D, E. You'll talk about a vending machine that has the state of, it's gotten 5 cents, it's gotten 10 cents, it's gotten 25 cents. Those are different states. With a flip-flop, a single flip-flop only has 2 possible states, on or off. So for a single flip-flop, has 2 states, and you can call them 1, 0. You can call them S1, S0. There'll be times that you might want to call them A or B, and you'll see what that is. So let's see. We are supposed to do the state diagram and state table for DT and JK flip-flop. Okay, so a state diagram and state table, those are different ways of representing our flip-flops. So let's do the D first, but to do the D, we will need its characteristic equation, which we didn't get a minute ago. We'll get it here. Okay, so remember that Q follows D. So the Carnot map is just showing us what the next Q will be. The next Q doesn't care what the previous Q was. So the next Q, if D is 0, the next Q will be 0. If D is 1, the next Q will be 1. So our characteristic equation for the D flip-flop is Q star equals D. I mean, that's about as easy a characteristic equation you can get. Okay, so that's our characteristic equation. Here's how we do a state diagram. So I have circles that represent my different states. So my two different states, I'll call them S0 and S1. You could also just call them 0 and 1. So those are my two states. And then it's going to depend on what my input is. And so depending on what my input is going to tell me what my next state is. So if I am in state 0, that means Q right now is 0. If I'm in state 0 and the next input I get is D equals 0. So I'm in state 0 and the next input I get is D equals 0. What state do I go to? Stay in 0. And we represent that with an arrow like that. And you can write D equals 0. I like to do it that way. You can also just write 0. You can also write D bar. Those are all things you can write. So for each state, I have to see what happens for every possible input. Now, I only have one input, so there's only two possibilities. My input is either 0 or 1. What happens if my input is 1? I go to my next state. So I could write this as D equals 1. I could write it as 1. I could write it as D. Okay, why don't y'all see if you can think of what to do. So that's it, we're done with state 0 because there were only two possibilities for our inputs. What would we do with state 1?
If D equals 1, it just goes to 1.
Yep. So that would be D equals 1. And if D equals 0?
Goes back to state 0.
Yep. D equals 0. Now our state table, I'm actually going to do a state table for our SR. No, I don't want to do a state table for SR. I'll do a state table for JK. So here's how a state table looks. So you have present state, and then you have next state, and with your next state, you're going to have columns for each possible input. So with a JK flip-flop, if our JK is 0, then that means that there's no change. So if our present state is 0, our next state will be 0. If our present state is 1, our next state will be 1. When K is 1 and J is 0, that's a reset. So our next state will be 0. When J is 1 and K is 0, that's a set. So our next state will be 1. And when they're both 1, our next state will be toggles. So this would be one way to write it. Another way to write this would be like this. I'm going to make several changes. So I can do present state. So I can assign these letters, S0, S1. And I could, if I wanted to, I usually don't do this. I usually like having like the reminder up here, but I could do J prime, K prime, J prime K, JK prime, and JK. So any combination of these things is fine. I'm just showing you different ways that you can do it. So in the first one I used 0 and 1, and the second one I used the letters. The reason you might want to do that is your states might actually correspond to something physical, and it'd be easier to have a name for it than a number. I like being able to just see, JK equals these. I like seeing it, but if you just want a shortcut, you can do that. Okay, well, unfortunately, I have to go, so I can't finish doing all the problems.